Good afternoon, my fabulous chemistry students. Mr. Milks here with our second to last installment of Unit 1 lecture videos. If you are watching today's lecture, you are on page 26. We're going to get through 28 in our packet, and we're going to learn how to separate different forms of matter today, okay? So first off, if I'm going to separate by density, an example of that would be oil and water mixture. If I let the mixture sit, the more dense liquid, the water, will fall, and the less dense liquid, the oil, will rise, and they will effectively be separated. Okay? If I separate by solubility, this is something like if I had a beaker of sand and salt mixture, right? Sand and salt. Well, solubility. Salt will dissolve in water and sand won't. So, of course, if I add water to it and stir, the salt will dissolve, and then I can filter out the sand from it and let it dry, and we're good. Now I've effectively separated the salt and the sand. I can separate by boiling point, called evaporation or distillation. Here, alcohol and water would do if I have an alcohol and water mixture, because the boiling point of water is 100 degrees and the boiling point of alcohol is about 85 degrees. If I were to heat that mixture up to about 86, the alcohol will boil off and turn into vapor. If I collect that vapor and cool it back down into liquid, I will have separated the two, and this does happen in distilling. Okay. Physical separation techniques, molecule size or magnetism. Molecule size, I could use just a regular filter. Like think of panning for gold, right? I could get the soil to go through and the gold to not because I want the big chunks of gold. Magnetism, iron filings and sand mixture. If I ran a magnet over the top of it, it would attract the iron filings and effectively separate the two. Take a minute, make sure you got all these written down. You can press pause, but I'm going to keep going to keep this video short. We have some apparatuses here that we will have in class to show you. The first one is filtration. I see the paper filter inside the funnel. I'm going to pour it through. Okay, this is a way to separate physically. I can physically separate the undissolved particles that remain on the filter paper because the filtrate or the liquid flows through the filter paper. Then we could dry it in an oven and we'd have it all set because we get off all the water. This is for heterogeneous mixtures. Think of sand and water. Easy to see. It's heterogeneous. I can see two different things. Hetero, different. Hetero is different. This next picture is the watch glass evaporation. I see the Bunsen burner with either the watch glass up top or the crucible on the bottom. And there's water in there. I'm going to kind of start cooking it off. But notice that the water on the watch glass, because it's higher, it's actually cooler than the bottom. It will condense there. And so this is another physical separation. I separate the solute, which is the solid that went in, from the solvent by boiling the solvent off. The solute escapes, so there's very little precision. What I'm trying to say there is you see the little wafting here? Well, that's some water vapor coming off, so I'm not collecting all of my water perfectly. So that isn't something that's a technique where if I'm trying to get all of the liquid off and collect it, I'm going to lose some, so this isn't going to be good for that. I use this for homogeneous solutions or mixtures. So when I look at the dissolved solid and the liquid, like say it's Kool-Aid, right? Oh, sorry, bell, guys. Sorry about that. They would look the same throughout. It's homogeneous, okay? It would work. Here is a distillation, which we just did on the last page. This is another physical separation. This is going to separate my two different liquids. So not a solid and a liquid, but two different liquids. And one has to definitely boil at a different temperature. Okay, so I can definitely boil one off at the one's boiling point, and they will separate. Again, homogeneous can be used to remove impurities from water, absolutely. So now we know how to separate different kinds of materials. Definitely do a YouTube search on distillations, filtrations, or even evaporations if you want to see some more examples of these things and get a better taste for how they actually work and why they are good. I will see you guys tomorrow in class. One more video left after this. Woo!